Hello, everyone, and welcome to our December Airflow Monthly Town Hall. Grateful to have you all here on the call. It's our last town hall of the year, so we're going to end it with a bang, and we have a jam-packed schedule for you today. We'll be covering our Airflow project overview, of course, with Yarrick. Then we'll jump into an awesome presentation with Kyle McCluskey, one of our Airflow champions. Then we'll jump into four different PR of the month presentations. And then I'll end with a quick, exciting announcement about Airflow Summit 2026. And then we'll let you all get along with your mornings, evenings, afternoons, or in Yonguk's case, middle of the nights. Next slide, please. Okay, so if you've been on this call before, you can tune me out for this slide. If this is your first time on a town hall, please note that no decisions are made during these calls. So any topics discussed here should be brought to the dev list afterwards. If you're not subscribed to the dev list, I'll include a link for how to do that later. And as always, this call is recorded and shared to the dev list and in the town hall channel in Airflow Slack, as well as on YouTube. You can just search Apache Airflow Town Hall, and all the town halls will come up on Airflow's YouTube as well. And with that, I'd like to jump into our first presentation with Yarrick.
Okay, hello everyone. I have only 10 minutes and a lot to tell, so I'll just go quickly. We had a number of releases this month. We were catching up with kind of like some of the bugs and features, and like mostly bugs and kind of UI glitches and all of the kind of small fixes here and there and bigger fixes in here and there. So we have lots of a number of releases, 3.1.2 with Caxil starting and going to the parental leave and Ephraim taking over. Then we have provider packages by Elat. Then, together with Bugra, we released Airflow CTL, first release 010, with first official release. That congratulations to Bugra on his work. Then we again had another patch level released by Ephraim. Then we had a Python client released, which was catching up with some of the changes in 3.1 that we added. And finally, we had lots of provider packages releases. There were like already four more, including the accelerated ones with me and Jens and Vincent will soon join us. I'll tell about more about the our changes in release management in a moment. And one of the important things, this release, the one of those releases was minimum Airflow version 2.11.0. So we are not in 2.11.0. You should upgrade because you will not get any more provider updates from us. Okay, different direction. Now going to the dev list, I try to sort it according to the type of discussions and voting and whatever we had in the dev list and in different kinds of communication. I will start with show and tell. First of all, Caxil had shown some like Airflow Breeze Manager for those who develop things on Airflow, kind of a way to switch easily between different Breeze folders and very easily switch between them, and that's really cool. I was trying it, I was using it. This is really cool. Especially if you are working on past versions of Airflow, that's really cool to be able to switch very easily. There is a workspace supporting Hatch added, which I explained. This is kind of like tooling is catching up with UV, so we are not that much tied with UV anymore because it is very close in implementation. So we are getting there in the kind of tooling is catching up with us. I asked also on the dev list to share your Gen AI contributions, and I repeat my ask. Please do tell how you are doing all the Gen AI things because we are at the beginning of the journey there. Every one of us has some experiences, and sharing them is really cool. Like Amok shared yesterday or this morning, even the commit tooling for to writing great commits, and like I really liked it. I haven't tried it yet, but I will definitely, and I encourage everyone to share their experiences. Then I boasted that if you have a free 1 or 2 afternoons, just you can read my boasting about the Alt Manager, which I explained the whole story we've done with Vincent and all the other people who helped. Go and read that if you want to see how things work here. That in just 2 years we have a something that we were thinking 2 years ago, and now it's realized with third-party Auto Manager added by someone else after we imagined that 2 years ago, and that's super cool. Uh, Okay, some things that about our DevTool improvements. This is something that we continuously do, as you might see from all the communication on the dev list. One thing, we got a lot of work on memory improvements with Kartikeya and Cengu, Arkadiusz, who was Ash, and I helped a little bit with all that. Uh, we had some very weird issues that we found very interesting issues, things that we've learned and improved already. Some of that is already improved. Memory is improved in Airflow in RC134. And also we have some explanation about that later. I will not go into details because this is a subject of today's town hall later. We have our Airflow components are now hot reloadable in Breeze and elsewhere, which means that you can very easily iterate on things because when you save your change, the component will restart automatically if you run in the right mode. This is really cool. Things think that this is adding a lot of speed to development. We have implementation of Task SDK integration tests done by Amok. We have like some really cool and some improvements which I've done on top of that, like consistent setup. So again, improving iterations speed on tests, which is actually cool because it was very slow. We have SQL Alchemy 2 coming, so we will probably very soon move to SQL Alchemy 2, and Vince and Delia are working very hard on that with a little bit of my help as well. Uh, we have new UI end-to-end tests added by Brandon and Ephraim. We're still iterating on them. They're in early phase, but they are going to help us to keep our tests, our UI not broken, and making sure that regression tests are running. And that's really cool. Something that we absolutely need right now. Finally, shared libraries extraction. We have a big team of people working on that now, like Amog and Christos now, myself. We are extracting a lot of stuff to the shared libraries, and it will help us with task isolation. And big thanks again to Christos, who helped us a lot with coming from outside and pointing out things that we should fix and improve there. Reminder that we are part of the Apache Software Foundation. This month was a little bit of like less of new features and more like cleaning up and like making sure we are good with what we are doing for in Airflow. So we formalized how we already run the Airflow survey so that we know next time that we know exactly how to follow and that everything is fine and nobody has complaints about like the ways how it's run and everyone can participate. We have some clarifications of meetup requirements. I added it. I haven't sent an email yet, but I will. I will soon. That was like more like explaining what do we do, like do we expect a little bit from our meetup organizers. Nothing special. It's just the usual thing, the kind of common sense. We have much more consistent and compliant with ASF requirements, the Apache org, Airflow Apache org website. So our website now is green when there is a tag in ASF on these different kinds of websites and PMCs. Our is green now, and we are keeping it green. There is a new podcast which we recorded, four of us, myself, Amok, Jens, and Rajesh. We recorded a podcast about how we work in Airflow in the way that is good for Apache Software, with like great for Apache Software Foundation. It's recorded by one of the directors of ASF, Rich, who is running the podcast, and I recommend everyone to look at it and to see how we work together here. And this is a like really cool 20 minutes podcast to look at, very easy. And we are working on Apache Trusted releases. Our releases will be much faster and easier to run with the tooling that is being developed in the Apache Software Foundation. We are making a lot of things clearer for our users as well. So that's another theme on our discussions. We are documenting how we should access metadata, how our users should access metadata in Airflow 3. We clarified that we are not exposing sensitive data over API and how we are handling fairness key approach. Amok, myself, and Bugra was working on that. Our Airflow site is getting a lot of small improvements. This is really cool because now, after all the investments we've done, it's really easy to develop and improve that. So we have like fixing download links across the place, which I did. Color for social icons when you hover over them by Larka. Footer hover on interactions, like when you hover over things, you can see things going on and like nicer UX. Block snippets were added by Alok as well. We have modernized our dependencies. We have scroll to top as of few days. So when you scroll too far down and you want to go to the top, you just click one button. It's not on all pages yet. It's on the main pages, but soon we will deploy it elsewhere. We have unified and that Abij. We had unified headers and white space, so our docs look consistent now. And Caxil is working on the fantastic improvement, which is dark mode for docs mode. Everyone wants it. We'll wait for him until he comes back from the paternity leave. We also improve our own processes. We're improving ourselves. We have the proposal for an updated provider governance process, which is being voted right now. Take a look and see if you are okay with that. If there are any comments, please. We are voting. The vote should end next week early, and we will continue with implementing it. So we will have hopefully many more providers in Airflow soon. We have now rotational release management with fixed cadence every 2 weeks because if we are three of us and hopefully four, we are looking for a new release manager as well to be added, another one with myself, Jens, and Vink. We are running rotation, so we can do fixed cadence more easily because we can replace each other if needed. And the big thanks to Elat who run our release provider releases for like 3 years or so, or even more. I can't remember. It was a very long time, and that was fantastic. Lots of heavy work for the community and cool. And we have a release plan, which we plan to update and iterate on. So look at that and see if it's useful, especially if you're a user and expecting releases, you can take a look and see what you can get from that and provide a feedback, and we will improve that. We also have version support for official Helm chart agreed by Przemek and started discussion and we have the now consensus that we will continue with whatever providers do in version support of Helm chart. We are also revisiting Helm chart support for database, and the conclusion that we have now is like there will be no database support out of the box, like the databases will not be included. You will have to have a database outside, which is actually quite a good idea. And we are continuously working on hardening our security with myself, Pierre, Ash, Jens, Amok, Vince, lots of discussion, lots of small things, depend about upgrades, cooldown, and we are all doing that while the whole world is literally holding their breath. Like every few days, there is a new attack on supply chain, on open source projects. And so far, we are not affected. Let's keep fingers crossed that it's going to continue because my friend was affected heavily. 24 hours of really huge stress with async API when they were hit. So we are working on making it not happen.
Hey,
Or
Yarek, we are gonna have to move on to the next presentation
okay,
because we're
we
over
have
time.
very vibrant community. We have the meetup in Warsaw. We have Rookie PR of the Month. Recordings are available from Airflow Summit, and we have the translation workshop. 314 RC coming. We are completing task isolation. We have a multi-team and asset partition and SLA in progress. State management discussion. Airflow 2.11.1 in progress. We will release it very soon. We are starting to work on tooling for provider stewardship and restarting on whole discussions for providers. Thank you very much. Sorry for being too long.
No, all good. Thank you, Yarek. And if anyone has any questions about anything that they just heard, please feel free to drop them in the chat and we will get to them during the next presentation. And Kyle, if you wouldn't mind sharing your screen, we can
Yes,
get.
please. Yeah, thanks. I'll send request to Yark to get the thank you. All right, cool. Okay, everybody can see me. Yeah. So thanks, Brianna, for reaching out to me to share a shortened version of my presentation from the Airflow Summit back in October. But I discussed a use case around election data. I worked during the presidential election for a firm that did some very specific kind of data engineering for ad targeting. And so it's an interesting use case, but more importantly, like from a technology application standpoint, it underscores kind of the principle of repeatable patterns across clouds and very specifically how Airflow can be kind of the common denominator across all of these different cloud-based applications that allow you to follow a particular pattern, kind of like a repeatable recipe, regardless of your cloud provider. So Let me switch here. So yeah, my name is Kyle McCluskey. I'm the data and AI solutions lead at TXI Digital in Chicago, where it's very cold right now. So if I'm going like this, is because it's like negative 20 degrees Celsius. But yeah, at TXI, we're a boutique software firm that helps legacy industries uh, modernize their infrastructure, and especially how everybody is looking to embrace AI. For to be able to do that, they need to get their data ecosystem in place and all of their data domains better managed first, and Airflow really helps with that. So in 2024, I had the opportunity to work for this company called Interval, and what they do is a very specific kind of precise ad targeting in the political advertising space. But they help with geographic data, demographic data, like very specific ideological scores that they plug into their voter profiling models. They make this information available as a data product to advertisers that are looking to target very specific subsegments of the population. And Airflow really helped us be able to implement this approach for multiple customers in multiple clouds. So to start with, let me go describe our data source. So we worked with a vendor that's very well known in the political advertising space called Catalyst, and they provide an overview of early voting data. So you don't see who an individual voted for, but you definitely see whether or not a specific individual, they have a unique voter ID. It's also tied to a social security number. You can see if they cast a ballot, in the presidential election, in the general, in the midterms, in primaries, off elections. So you get a profile of voting behavior, if not a very, specific, like, oh, they voted for candidate A, B, or C. But you can infer certain kinds of things about the ideological leanings of the voter, like if they voted in a party's primary, whether it's Democrat or Republican, you can kind of infer certain things maybe about their ideological bent if they voted in 3 of the last primary elections for a given party. The Catalyst also provides certain kinds of proprietary ideological scores, like likelihood to be conservative or progressive, based on things like primary participation. These data feeds originate at all the different 50 Secretary of State's offices. So they all have kind of different formats and cadence. And what Catalyst does is it takes all that in, it normalizes it, it provides it as a feed to its subscribers, of which we were one. And then you can use this early voting data to enrich other models that you have of voter behavior. And so, like I said, the data products that were produced by Interval with some very specific scores of what's the likelihood that we think a particular demographic subgroup or geographic subgroup is going to be responsive to this kind of a message. Are they going to be able to see a message if it's delivered digitally as opposed to maybe through like traditional linear TV? What are the different dimensions upon which you can slice an audience? So there's demographic information like age or race. There's geographic information like state or zip code, and there's other ideological scores like what I said, maybe an individual voter's propensity to be concerned with educational policy or energy policy or the climate, and some of that is based on voting behavior, some of that is based on commercial behavior. There's some of that is based on who you stream or not, who you're subscribed to, and there's a lot of other kind of like backing data sources that go into this data source to come up with those scores. But the takeaway of it is for the purchasers of these data products, they don't want to target a voter if they've already if they've already voted. So this helps us kind of identify these particular subgroups you could potentially get your most bang for your buck if you spend your money there. So it is not an ETL process. So we're not taking like a transactional data store and turning it into a warehouse. This is ELT. So we have the third-party data source from Catalyst. We store all of that raw first. So we need an object store. We need a data lake. The nice thing about all of the different cloud providers is that, AWS has S3 or Azure has blob storage, Google has the Google file service. You can, across any of those clouds, use that same kind of cloud offering to as your data lake to put your raw data in. The nice thing about Airflow, of course, is that it has operators that can hook into all of those different platforms. And so again, like Airflow is the common denominator across all these different clouds, that it doesn't matter what your provider is for your data lake, you can put your raw data in there. We index it by time and state, but like no other kind of enrichment or transformation. We just want to know, what data came in when, and a simple JSON format. So this is a rough little diagram of how Airflow helps us orchestrate the API call, the raw data storage, and then it passes it off to if we had implemented this in Airflow 3 at the time when we were delivering it, we would have used this early voting data as like a data asset. Like as it got updated, it triggered all these other downstream consumers. At the time that we implemented it, we had to explicitly call all of these customer-specific downstream transformation services. We used in Google Cloud Platform. We kind of started our first kind of reference implementation of this using Google Cloud Run service. But Airflow could check for updates. It could make the API call to store them, put the responses in the lake, and then trigger that downstream processing in any of the clouds that we have. So like I was saying, the data product that's bought is what is the likelihood that individuals with college degrees that make this much money that live in this zip code are likely to be responsive to your message or not. In addition to that, if that's enriched with which subgroup of those voted or didn't vote, then it becomes a very meaningful and valuable data source to your consumers to say like, oh, this is how I want to spend my money, and this is where I think the most gain to be had is like in these very receptive sub audiences that don't have a lot of early vote out there yet. So we output them in Parquet, but the nice thing is we could have one Airflow pipeline to get the raw data, to store it, and then to trigger all these different downstream consumers. Serverless compute was another really nice option. Like if we knew that there were multiple different clouds that we wanted to run this in, we could share, and we had multiple consumers that wanted the data. We could share implementations, maybe of specific functions, specific transformations that happened for more than one customer, but it wasn't common to all of them and couldn't be in like a general pre-processing step in Airflow. So by using serverless compute, it allowed us to abstract some of that functionality out and import it in different functions. It's also more scalable. So if a big burst of historical vote data came in, or there was a really active day pre-election, we could elastically scale out and handle that. And for a small startup, it was nice to have on-demand pricing as well. And then there were times when we were doing kind of one-off analyses or demos for customers, and so using serverless compute allowed it to be executed outside of Airflow. If we wanted to, we could have also just manually triggered a DAG, but sometimes it was nice to not need Airflow. So, like I said, these patterns are repeatable. Whether it's you need data lake, you need serverless compute across all of the different public clouds, you have that. But then the really nice thing of using Airflow as your general orchestration layer, all these public clouds have a managed service, or Astronomer, has their own managed service that allows you to bring your own cloud to it so that their managed Airflow can run either in AWS, Azure, or Google. So, it's nice that you have the three public clouds and Astronomer with a managed Airflow, so that part doesn't need to change. And then whatever flavor of data lake or serverless compute you want to plug in here for your specific ELT use case, this is just kind of like a repeatable pattern that allows you to plug that in. And especially if you use something like infrastructure as code, like Terraform or something like that, you can create a Airflow like based ELT pattern across any cloud that you want. This is a graphic showing how what it would look like in GCP versus AWS. But that's kind of the point that I wanted to make, is that if you base your solution off of Airflow and these common cloud components, and Airflow is the most common denominator across all of these clouds, it allows you to build repeatable solutions. I had the opportunity to put a more in-depth kind of description of what we did on the Apache Airflow blog right before my talk. So if you want to get more information on what we did, it's in there from early October. And if you want to talk more about the solution or about this kind of pattern, my email is here. I'm Kyle@txidigital.com. But this was a very helpful pattern for us, and I enjoyed having the opportunity to share it with the community in Seattle last October. So thanks, Brianna, for the opportunity.
Of course. Thank you, Kyle, so much for sharing. And I just posted his article in the chat here. And with that, Sebastian, you are up next to chat about your PR. Would you like me to share my screen, or would you like to share yours?
Can you hear me? Sorry.
Yes, we can hear you.
Perfect. I can go next, but I think looking at the presentation, it's Among that should be before me, but I don't care in which order.
Oh, you were right. I scrolled down too far. Amag, would you like me to share my screen, or would you like to share yours?
I'll do it.
Okay, great.
All right, so let me quickly share my screen. So, can you see my screen?
Yes, we can.
Okay, I'll start. Yeah, so hi everyone. I'm Amok. I'm a committer and PMC at Airflow, and I work as a senior engineer at Astronomer.
Amag, can you go
So,
into slideshow mode?
yeah, I want to do something first and come back.
Oh, sorry.
I'll do it, yeah. So yeah, right. So yeah, I want to talk about my PR from last month, which was to move the Airflow config parser to a shared library, and this was the PR. So yeah, don't worry, I won't be really going through this, and that's why I've created a presentation. I do not intend to do a code walkthrough here. Right. So let me start. Okay, so a slight introduction slash context slash why it's important before we start. So from Airflow Summit and from the last couple of months to almost a year, you would have noticed that Airflow is slowly maturing into a client-server separation model. And what I mean by that is when I say server, it's the Airflow core, which is your scheduler, API server, as well as the metadata database. And if this is the core, the consumers of it are the components that install this software called Task SDK, which runs on your workers, your triggerers, and DAG processors, anything to do with a DAG author. And this communicates to the Airflow core or server using the task execution interface. Right. So you also must know that Airflow offers a configuration pie. It's a super huge file that boils down to giving you a configuration object. And if you don't know what I'm talking about, you'll probably be more familiar with things like this, right? All across the code base, you would have seen things like this, conf.get and so on and so forth. So obviously configurations is a way to customize your behavior, and Airflow core needs it because take this classic example of it needing executor, and Task SDK on a similar hand needs at the very least it needs a API base URL for it to know where the API server lies to communicate to, or the logging base folder, because task needs to generate logs. So what happens now? This is a simple find window of me trying to search airflow.configuration present in Task SDK. And okay, this is before my PR got merged. Yeah. So you can see that there are about 24 occurrences of this, and this is creating unnecessary coupling between the two different libraries now. Task SDK is trying to get configuration from Airflow code in 24 different places. So what's the solution to such problems? It's something we came up with known as shared libraries. So shared libraries is pretty self-explanatory, but still, these are packages that are shared across Airflow distributions, such as core SDK providers and okay, Airflow CTL as well. And it's a simple means to just very cleanly say that let's avoid plain duplication. And how does it work? Is a shared library has a couple of properties. The first one is obviously it lives in the shared folder at the top level of your Airflow repository, followed by it being symlinked into the consuming libraries such as the core or SDK during development. And once when we are trying to release it, it's rendered in or copied as part of the distribution it is part of when we are releasing it. So a simple question might be, why not just use regular PyPy libraries? So it's simple. We don't use PyPy libraries because we are just offloading the problem elsewhere. If a package A is depending on a PyPy library and a package B is depending on it, it creates a problem of a compatibility matrix in terms of versioning and obviously dependency conflicts, which is possible. So coming to the configuration section, what was actually moved into the shared configuration library? So the working principle here was very simple. Let's move the config parser class in its entirety to a shared library. So what does that mean? It's obviously the access methods, your get star methods, get boolean, get int, etc., followed by reading and writing configurations. And similarly, things like reading and writing configurations, not writing, but reading configurations from things like your envs, command, secret backend, config file, etc. in a sequence. And obviously deprecated options and section handling. And to wind it up, the sensitive value masking as well. Yeah, a lot more. So simply in terms of what was not moved is anything to do with providers. We do not want to move anything related to providers back into the shared library because this will again start to create a dependency through the provider because shared library will start to depend on it. So things like dynamic provider config loading and fallback options for providers. And the validations, things like the SQLite version checks, your enum validations and database migration logic that is not relevant to all the consuming packages. This is only relevant to Airflow code. And things like your template variables, Airflow home and fernet key do not make sense to Task SDK. So it's better it lives outside and stays in code. So I figured that it would be better if I modeled this into a UML diagram to show it to you. So I think, yeah, I did something and this is how it looks like. Yeah, it's too big, but let me show you a very brief version of it. So our Airflow config parser, it inherits from the config parser of Python standard library and defines a whole lot of things on it. And now with this change, the new do I move? Yeah. With this change, the new core config parser that is trying to extend the base one inherits it and overrides only what's necessary. For example, I mentioned things like providers, right? Load provider configuration, a few more things like validate SQL version, the enums, etc. And Task SDK inherits again and overrides a few more things, but you can see it has nothing to do with providers or validations here. So yeah, I have attached that here. Go back into slideshow. So yeah, that's pretty much what's been done. But in terms of what's coming, we have established the foundation here, which will help us into moving to the next stages. So the next stages are namely, we split the configuration into SDK and core configs. And when I say SDK, it's authoring related configurations. Similarly, core as in the deployment related ones. And once this is done, providers only consume from the SDK configs. And phase 3 is simply just being more efficient. We implement some sort of lazy loading on the provider configs. As of today, just to get a conf object out, you need to load configs from providers, and it makes it bulky. So we just load when it's accessed. Okay, there's a typo. Anyway, yeah, that was me. Yeah, you can drop your messages in Zoom chat, and I'll answer for you.
Thank you so much, Amag. I appreciate that. Appreciate you joining so late in your evening as well. Next up, we have Sebastian giving a PR presentation. Sebastian, please share your screen when you're ready.
Yes, give me a sec, please. Let's test if that works. So you should see my screen, is that correct?
Yes, we can see it.
Let's try with the presentation mode, still there?
Yes.
Perfect, cool. So yeah, I'm Sebastian. I'm senior data engineer at MediaMarkt Citroen Technology, and yeah, I have some slides about the PR 56911, a nice number, which covers adding async Discord notification. So what I worked on is, yeah, giving the feature of sending a Discord message asynchronously. So this feature allows you to use a custom trigger or like deadline alerts via async callbacks to now send Discord notifications via the triggerer. So before that, it was only possible to use it via operator or hook in a sync manner. Now this is possible over async, which is of course nice, a bit more efficient. And here this just presented a small code example how you can use that. It's very simple. You define a DAG ID, and then I basically use the deadline alert. This is a new feature, great new feature, which the interesting part is the callback section. So have a look at the callback where we define an async callback, and then you pass in the Discord modifier and some keyword args such as the text or other that you need to render or send this Discord notification. And in that example, whenever the deadline is retrieved, basically the scheduler will notice that and send that back to the triggerer, and it will send this notification then to Discord. Yeah, this is it actually. This is how it looks like. Nothing new, right? It was before already in the provider code base. But yeah, just an example what you can get out of it. There's also more about Discord notifications. There is another PR opened by me a couple of days ago, which gives you, whenever the review is done, hopefully the functionality to add some more styling on Discord messages. There is a thing called Discord embeds, and this is just a nice feature that allows you to really customize the messages itself with order information or footer providers, custom fields, stuff like that. Really nice. And yeah, I made a suggestion how to implement this, and yeah, maybe this is also something that you can use also in the future then. And last but not least, there is even more. So I just tried to put down or summarized the efforts that some of us took in the last weeks and months to work on this async notifications support. So there is the meta issue created by Dennis, I think, 55237. And yeah, I just provide you some information about what went live already, what we merged, what we offered. So Dennis worked on a lot of AWS thing, SNS, SQS, SES, and so on, but also the SMTP. I worked on the AppRise notifier, Jira, PagerDuty, Slack, and Discord. Ramit is also here. I think he worked on Slack, and Sean worked on HTTP notifiers. So all this went in the provider code basis. That means all of these notification can be used by you in this async mode via triggers or async callbacks, which is great. And yeah, have fun using it. And if there are any questions, feel free to ask. And that would be all from my side.
Thank you so much, Sebastian, for sharing and jumping on this call. All right, so we are going to hear from Jong Woo on his PR now. Jong Woo, whenever you're ready.
Yeah, I'm ready. Hello, I'm Jong Do, a data engineer and labor veteran. Today, I'd like to introduce a PR that I contribute to Airflow. I sincerely appreciate everyone who selected me for PR of the month. Could you go to the next slide? And first, let me introduce Memlay. Memlay is a powerful memory profiler for Python applications. Its key feature is the ability to track every memory allocation that happened during program execution. It also includes great visualization tools which help you easily understand memory usage patterns. You can quickly see which function use how much memory in several different output formats. Yeah, could you go to next slide? Now let me explain why this work was needed. After Airflow 3 was released, many users began reporting memory growth issue. While investigating this issue, Yarek suggests that I try analyzing them using Memlay. Following this, I successfully identified the root cause of memory leak issue. Shortly after that, cashier's work resolved most of those issues. However, the problem didn't end there. Even after those fixes, users continue reporting new memory leak problems. Through my analysis, I found the memory leak generally fall into three categories. First, hidden memory leak in Airflow core logic. Second, kernel-level memory issues such as RAM memory. Third, memory leak in user-defined code, especially in task logic running inside worker processes. Next slide, please. So if memory is available, why is still difficult for user to analyze this issue themselves? In my case, to use memory inside Airflow, I had to manually modify the Airflow source code and insert memory API directly into components like the scheduler. For example, I had to leave section of code with memory tracker. This required deep knowledge of Airflow internals, and after modifying the source code, you also need to build and maintain a custom Airflow image. So I thought, what if we could generalize this process and make memory profiling much easier for Airflow users? Okay, go to the next slide, please. The solution I propose is very simple. I create a Python decorator that left the memory API and applied it to the entry points of major Airflow components. Now, user can enable memory profiling simply by adding a setting to the Airflow configuration file. No code changes are required. When the component runs, memory automatically starts tracking memory allocation, and the profiler output is generated in user's preferred format. Yeah, next slide, please. Of course, this approach has several limitations. First, tracking shared memory is difficult, especially in local executor, which launch multiple subprocesses. Identifying memory leak in shared memory between processes is outside memory's capabilities. As a side note, I made to discuss this issue and potential solution, so I'd appreciate your attention. Second, memory cannot track object created before profiling begins, such as the configuration object loaded during Airflow initialization phase. Anything created before memory is activated is not captured. Third, kernel-level memory issue like SLAM memory leak cannot be tracked by memory since it's focused only on Python in-memory allocations. There are several improvements that we can consider working on. First, there was a feedback and it would be good to add the ability to turn memory tracing on off dynamically without restarting the components. Second, I hope to this feature to persistent workers such as salary workers. Since our user-written DAG and test code run there, this would make it much easier to identify memory growth issue caused by user logic. Yeah, I hope this feature help memory airflow user with memory debugging. Thank you.
Hello everyone, I'm Ramit Kataria. I'm a software engineer at AWS and a contributor on the open source team for Apache Airflow. I'll be talking about two of my PRs for introducing sync callback support um, on executors. So for some context, deadline alerts is a more robust, reliable, and more customizable replacement for the SLA feature that was present in Airflow 2, but was removed in Airflow 3. It allows users to specify callbacks to run when a diagram misses the deadline. In Airflow 3.1, when the feature was launched, only async callbacks were supported, and those run on the trigger. As for sync callbacks, they would be running on executors, and currently that's work in progress. So essentially, for running something on an executor, it requires a workload, and currently it is, I guess the way it's implemented, it's supposed to be a generic workload, but in practice, it's highly tied to the task instances. And so I guess there's some quite a lot of work needed for in executors to be able to support these callbacks. Maybe next slide, yeah. So for supporting these callbacks on executors, I considered multiple ways that we could go about this. One way would have been to just use the execute task workload, which would not have been a good idea at all because its tasks require very different inputs and runtime behavior than these callbacks. And it would also be against the spirit of the generic workload class, which, like I mentioned, is implemented, and the executors are supposed to be able to take multiple kinds of workloads, but currently there is only one actual workload. And so I guess this is going to be a good use case for these for another kind of workload to be added to executors. And so for this new workload, there's also, I guess, multiple kinds we consider, right? So there's one way we could do this by making a workload specifically for deadline callbacks. This would have been probably a bit easier to implement, but then this would be tied to only deadline callbacks. And in the future, maybe we want to move this to or like have other kinds of callbacks, like the on success or failure callbacks that currently run on DAG processor to these executors. It would again require changes, and changes in these workload types are not just Airflow core internal changes. They also need to be essentially get added support for in the actual executors, which which are also in providers as well. So it's more of a public change when you make a change on these workload types. So essentially, I settled on creating a new generic callback workload, and Yeah, and then this would support both for now the deadline callbacks, and in the future, I think there's an AIP. I think it was AIP 92, which mentioned moving the DAG processor callbacks over to executors, and so in the future it could be used for that as well. Next slide. So in these PRs, here's a summary of what I implemented. So essentially, there's a new workload type for executors. It's called like an execute callback. A new DB model for callbacks. So currently, there's a DB model for deadline, and there's one for um, there's one used for the storage of what's it called, the DAG processor callbacks in the database, right? So essentially what I ended up doing was moving the callback components of the deadline callbacks from the deadline table into this new table, and also moving the DAG processor callbacks to this table. And so this supports multiple kinds of callbacks. And so I ended up using SQL Alchemy's polymorphism features, which are very handy here. And also, I also refactored the DAG processor callbacks to use these model classes instead, and use to reduce redundancy. But for the DAG processor callbacks, there's no functional change here. We're just changing the way that they're stored. And this also involved some non-trivial DB migrations for these model changes. For the yeah, depending on how much time I have, I'll go over these as well. But essentially, I focused on correctness over performance because of a few reasons. So there's the actual complexity of the representation of how these callbacks and definitions and essentially all the callback metadata was stored would have been I guess quite complex to implement in SQL, and it would require different queries for each kind of database that we support. So like different for MySQL and Postgres and SQLite. And also, like considering the expected, like this is not like a, like the task instance table. So this is we're working with the deadline table, which only stores historical data for only for missed deadlines. So the table would only essentially contain either missed deadlines or deadlines for diagrams that are in flight during the migration. So it shouldn't. So and this feature also was just recently released, so we're not expecting huge table sizes here. Certainly, less than a million, probably in most cases. And also the testing coverage for migrations doesn't seem to, like as far as I can tell, the migrations don't seem to have like a good process for testing, and it was a lot of manual testing. So I wanted to make sure that they were, focused on correctness to make sure they were correct or the performance, and I ended up implementing them in a way so that I have only like one script in Python, um, and made sure that is correct over implementing a different migration for each kind of database. How are we doing for time? Do you think I can go over a little bit of the code?
Yeah, we have 4 minutes left in the call in total. So as long as we have 1 minute at the end, we'll be fine.
All right, sounds good. So I'll share my screen. So I guess first thing I'll go over like the new callback model. Um, this I've designed it to be as generic as like any callback would require being, and not make it too specific to like deadline callbacks or any other kind of callback. And yeah, essentially I'm trying to make it as modular as possible. You'll see like there's enums for like different kinds of the different places that these callbacks would be able to be executed. And some of these require different ways for how you would be able to fetch them. So for example, for DAG processor callbacks, they use a DAG attribute to fetch the callback. But for these deadline callbacks, they use import path. This is just what the table looks like. And so there's for concrete classes, there's a trigger callback that runs the async callbacks. There's the executor callback. This is the model class that will be linked to the execute callback workload for executors. And then this is just moving over the older functionality from the DAG processor callbacks, where this is how it's essentially stored in the database. And then in my second PR, I worked on the migration for moving over the deadlines, like the deadline callbacks over to this new table. And as you can see, like this requires, some logic because of some changes. And taking all this into account in SQL would have made it, I guess, more complex and more prone to errors. This is all done using just Python. And still, I try to, keep it as performant as possible. I'm doing it in batches. And there's still some, improvements that can be made. Like there's, I know Amog, you pointed out something that I should work on. So that's coming soon. Yeah, and then the rest of it is just refactoring the deadline callbacks to use this new model class. But yeah, I'll stop now since we have just 1 minute left. I guess let me know if anyone has any questions.
Yes, if anyone has any questions, please drop them in the chat for Ramit. And Ramit, thank you again so much for sharing and for everyone who shared on today's call. I know it was a lot of content, but you all came out and showed out, so I really appreciate that. Just want to give one quick announcement before we drop. Drum roll, please. If you haven't heard, Airflow Summit 2026 will be taking place in Austin, Texas. So we're really excited to share the exact date with you as soon as possible, but likely sometime in September, October, but TBD. We'll be in the fall. We'll be in Austin, Texas. Really excited to hopefully see many of you there as well. And with that, I will go ahead and let you all go. Have a great rest of your Friday and Happy New Year. If I don't see you before then, bye everyone.